Hello everyone, my name is Marco Pérez, and I am a student at a chemical engineering school in Mexico City. And the topic that I will talk about is the rheological characterization of styrene-co-acrylonitrile copolymer solutions reinforced with carbon nanotube sponges. The purpose of the work is to study the effect of the addition of carbon nanotube sponges in solutions of different compositions of the copolymer. The addition of the sponges was carried out in three different series. Series A with 0.1%, Series B with 0.3%, and Series C with 0.5%, all percentages by weight. 4 solutions were prepared from each of them, just varying the composition of the copolymer added. In Series 1, we have 0% styrene and 100% acrylonitrile. In Series 2, 20% styrene and 80% acrylonitrile. In Series 3, 40 and 60%, and finally in Series 4, 50 and 50% of each monomer, resulting in 12 different solutions. All of them were characterized by storage and loss modulus in a temperature ramp analysis from 30 to 130 degrees Celsius. For a better understanding of the results, it is important to define some concepts, as well as explain the manufacturing process of the solution. First, to understand what carbon nanotubes sponges are, it helps to first understand what carbon nanotubes are. These are allotropes of carbon, just like graphene. In fact, it is easier to visualize carbon nanotube as cylinders formed by rolling a sheet of graphene around an axis, and sponges are very similar structures with the addition of boron, resulting in the branching of multiple cylinders. These branched nanotubes have interesting mechanical and electrical properties that are incorporated into the mixtures in which they are used. Styrene-Co-Acrylonitrile has numerous applications in various areas. Its most commercial composition is around 80% styrene and 20% acrylonitrile by weight. In this mixture, the concentration of styrene is associated with greater ease of processing, as well as some aesthetic characteristics, while acrylonitrile provides greater chemical and mechanical resistance. The copolymer solutions are viscoelastic material. This is important, which means that they simultaneously possess characteristics generally associated with solids and liquid fluids. For the study of this type of materials, there is the gain modulus G prime, which mainly describes the solid or elastic component of the material, and the loss modulus G double prime, which similarly describes the viscous nature of the material. For the manufacture of each solution, the same methodology was used, which consisted in the dispersion of carbon nanotube sponges in the methylformamide by means of sonication for 2 hours at 500,000 joules of energy. Subsequently, 10% by weight of the copolymer was added to the composition of each series, and it was left under magnetic stirring at 60 degrees Celsius for 12 hours. For the results, first, I didn't mention it, that the characterization was carried out in an atom par MCR 502 atom par rheometer. And these three graphs, this is graph number 1, and these two are graph number 2 and graph number 3. Well, these three graphs represent the variation of carbon nanotube concentration on series 2, whose composition is 20% styrene and 80% acrylonitrile by weight. In the three graphs, the dotted line formed by triangles represent the change in the loss modulus, while the line formed by the squares represent the change in the gain modulus. In the three graphs, a similar behavior is observed, where the yield point is around 118 degrees Celsius. In addition, it can be seen that up to just before 120 degrees Celsius, there is a usual viscoelastic behavior, where the gain modulus is lower than the loss modulus, and both get closer until they commute on the same temperature value, and after this value, the gain modulus exceeds loss modulus. What is peculiar, though, on this occasion is that the change in the trend corresponds to the glass transition temperature of the copolymer, but shifted slightly upwards due to the effect of the carbon nanotube sponges. In the case of the first graph, which contains the least amount of sponges, it is not fully appreciated. However, in the second, where the concentration is 3 times greater of the sponges, this change is seen at least 2 degrees higher. And in the case in the third graph, whose concentration is 5 times higher than in the first, the change in trend occurs up to 5 degrees above the normal glass transition temperature of the copolymer, which is around 110 degrees Celsius. Finally, and to conclude, the highlights of this work are that at a higher concentration of sponges, a higher elastic modulus was observed, which translates into a lower viscosity, especially in solutions with a lower amount of acrylonitrile. Also, the presence of carbon nanotube sponges shift the glass transition temperature upwards of the copolymer. We believe that this occurs because the reinforcing matrix makes it difficult for a few degrees Celsius for the ordering of the chains to occur in the usual way, since the sponges have considerable thermal conductivity, which increases the net heat that the material can absorb. Also, if you want to know more about the rest of the solutions, the rest of the 12 solutions, here you can check this QR code. Here you can check a PDF where the 12 solutions are analyzed. So thanks.